Greetings all. I want to review a quiz that I will do on the RSA protocol, and it's pretty straightforward. So I'm going to give you two primes. Of course, there are secret primes, so I'll write them in red. P is 71 and Q is 101. And so now you have to set up the protocol, and I want to use E, the exponent, the encryption exponent to be 97. That one I choose because trust me, I make some choices that makes it a little bit easier to calculate things. Okay, and so the first question would be, for instance, using this protocol, right? So Bob wants to send. So Alice is doing this, right? So Alice is setting this up. So this is the data that she's going to start. That's not everything, right? There's more that has to be done here. But so the first thing is Bob wants to send the message M is 196 using this protocol. So does he have to do? Well, first of all, Alice has to do something more, right? So N, she has to publish N, which is 71 times 101. Well, I should write this in black, I guess, or in red or whatever. Perhaps in red even. 71 times 101. But it's the product itself is something that she makes public. That is 7171. Okay, so that's all Bob needs to know. So N is 7171. Here's now the secret exponent. The public key encryption and the modulus. Okay, so what does he have to do? His task is very simple. He has to take M. So that the coded message C. What is that? That is M to the power the public key modulo the public modulus, which is 71. So in this case, this comes down to 196 to the power 97 mod 71. Now I want you. I'll make this clear, but already listen to what I'm saying here is I want you to show me all the calculations in when you have to take when you do this is going to be modular exponentiation. I need to see all the steps in that. Okay, so what do we need to do? Well, the first thing we need to do is to write this exponent as powers of 2, because we're going to keep squaring. So that is a 64 in there. Then what is left is a 33. Yep. Oh, that's easy. That is 64 plus 32 plus 1. So not too bad. Okay. So these are the 3 powers that we will need. But of course, we have to start from the first power, 196. And so this is always modulo 7171. So we get 196. The next one is 196 squared. Right, so that's what that. And again, also this part, I want you to show me all the steps. You have a whole day, so it's not, don't say, oh, this is too much work. 196 squared. So this is 38,416, and we always work modulo 71, so divided by 7171. That is 5 times 7171. That is and subtract 38416. That is 2,561. Okay, right? Then we square again, which means that we're going to square this guy. That is 6558721 divided by what is it? 7171. That is 914. That is 914 times 7171. No. 914 times 914 times 7171. That is then subtract 6558721, that is remainder 4427. All right, so we square this one more time. That is 4427 squared, which is 195,98329. That is 2732 times 7171. 2732 times 7171. That is that number minus 195,98329. Okay, that is 7,175. Okay, let's square that again. 196 to the power 16, so we do 7157 squared. You could here subtract 717 from it, because that's going to give you a much smaller number, right? So let's do that perhaps. So this is the same equivalent to, so I have what, 7157, and I subtract from that 7171, that is minus 14. So this is, so it is, it's often not really that much of an advantage, but okay, in this case, much easier number to deal with. So this is 196. Now, pay attention a bit. 196, we have that already, right? So 196 is 196, but this is going to be very fruitful for the next thing. So we now have to do this to the power 2. So we have to do 196 squared, but we have this. Right, this value we know, this is 2561. So now we have to do 196 to this. So always be on the lookout for patterns like that. They're not always going to be patterns like that, but it could be. Okay, so we have to now do 2561 squared, but we have also calculated that is this number. That is 4427, and oh, that's all that I need, right? So because what I need is 64, 32, and 1. So 1, the 32 power, and the 64 power. So what this code, the coded number will be is 196 times 2561 times 4427. Now, of course, this we have to calculate. So that is 196 times 2561. We divide that is, okay, let me write it down. This 501,956, 7171, that is 69 times 7171, so 69 times 7171, and subtract from that 501,956. So yeah, okay. That is plus 7157. Now that one I can again try to write the negative number because it's a rather big number, or I can keep it. Let's try to be smart. So you can also say this negative 14. So this is equivalent to negative 14. Oh yeah, right. We have this number already here, right? See, the number is there. Okay, so that is negative 14, and so now we have to do negative 14 times this guy. So it's negative 14 times 4427. Times 4427. So that is, yeah. You know what, I'm not going to do negative 14. I don't want to work with negative numbers when I do these modulo calculations. It's okay, but 7157. Let me just do it this way. So 7 157 times 4427, and divide that by 7171. That is, so this is equal to 4480 times 7171. Oh, I have to remember this one. Okay. Okay, 4418 times 7171. That is this number minus, I forgot, 7157 times 4427. And that is, seems to be plus 2561. Now, that gives me 1 sec. What is the power that I'm doing? 97, right? Okay. So, sorry, 2561. Okay, so that is correct. So we find that our encoded message becomes 2561. Okay, so far so good. That's part one. It's a bit of calculation, but as I said, once you recognize that there's a pattern, the calculation gets much compacter, right? So the next thing is, the second thing is, now suppose Alice wants to decode this message, right? How does she decode this? In other words, let's call it just said that, what is Alice's decryption key? So what is D? Because that is something she needs. We haven't calculated that, so let's do the calculation of D here. Okay, so for that we need to also work with this number, secret number, which is P minus 1 times Q minus 1. So in our case, that is 70 times 100. So in other words, that is 7,000. And so what we need to do now, we know that D is going to be the inverse of E mod that capital N, right? So what does that mean, our equation? What does that mean then? Let's go to in black again. Oh, no, not this black. So D times E was 97, E times 97 has to be equivalent to 1 mod 7,000. So what we need, how do we solve this problem? That is Euclidean division, right? So we use the Euclidean division algorithm that allows us to calculate the Bezout form from which we find the inverse. Okay, so here we go. So 7,000. 7,000, how many times? Divided by 97, right? And so these are the numbers that I'm going to have to keep track of. So 7,000 divided by 97, that is 72. So 72 times 97, and that is 16. Correct? Right, okay. So 16. So now we do 97 divided by 16. That is 6 times 16, which is 96 plus 1. Oh, that is rather quick that we got to our solution. So we see that 1 is equal to 97 minus 6 times 16. So now this was the forward calculation, this is the backward calculation, but okay, yeah, I started on the top, so... Okay, what I mean is I use this equation to find 97 minus 6 times 16. Then I use this equation to replace 16, that is 97 minus 6 times 7,000 minus 72 times 97. Okay, and then we group the circled numbers together. We have 72 times 6, 432, so this is 433 times 97 minus 6 times this guy. So let's see, double checking that everything is okay. 433 times 97. Yes, that is 42,001, and of course 6 times 7,000 is 42,000. So that is correct. Always double check your numbers here, right? So what does this now mean? This means that if I take modulo 7,000, this term disappears because that's modulo 7,000. So we have this is 43 times 97 modulo 7,000. So so this means what? That D is 433. Okay, and now last question. Say she receives a message, say from somebody else or from Bob again, sends a message, and the coded message she gets is 2020. Okay, so what was the original message? What is the original message? Okay, I'll write cryptic, but on the test I'll write it in words. Okay, so what is that? What is she does to do now? So to find the original message, she takes the encrypted message, applies her secret exponent, and takes again residue modulo the modulus that everybody can see, so modulo n. So in our case, this means what? She takes 2020, puts it to the power 433 modulo, and n was 7171, right? Okay, so now we have to calculate that. How do you do that? Well, again, I want you to show you the steps. It's modular exponentiation. We've done it here, so we do it again. 433. Well, that is 256 plus, let's see, 433 minus 256. That is 177. So that is 256 plus 124 plus 53. Okay, what goes in there? We have a 32 in there. 256 plus 124 plus 32 plus 21. Okay, so there's 256 plus 124. 124. Where does 124 come from? Hey, oh, sorry guys, I forgot my powers of 2. 128, of course. So it is 128, and what is left is okay, 49. And there I can have a 32. So I left 256 plus 128 plus 32 plus 17, and that one is 256 plus 128 plus 32 plus 16 plus 1. So these are the powers I need. And all right, here we go again. So this will be again mod 7171. Here we're going to take the powers of 2020. Okay, so 2020 to the power 1. That's of course just 2020. 2020 squared divided by that. Okay, that is 408,0400 divided by 7171. That is 569. That's 569 times 7171. 569 times 7171. That is that, and then subtracting. That is seems to be 101. Okay. Okay, we square again. That means we square this guy. So 101 squared is 10,201, and we divide that by 7171. Well, that is only 1 times, right? That is 7171. So let's get this. So 10,201 minus 7171 is 3030. So this is just 3030. So this was 101, right? Okay, let's square again. This is 2020 to the power 8 is the same as 3030 squared. Okay, 3030 squared. That is 9180900. That is 1280 times 7171. What is this thing? Sorry guys. And subtracting 9180900. That is 2020. Ah, that is nice, because I have already 2020, right? Did I? Yeah, I've already found this, so that's good news again. So what is the next one? 2020 to the power 16. Well, that is 2020 squared, but I know what that is because I calculated it. It is here. It is 101. And so then 2020 to the power 32. Well, that is 101 squared, but I know what that is. That is this one. That is 3030. So 2020 to the power 64. That is 3030 squared. But that's 2020. Okay. And we are back 2020. So 2020. How far do we have to go? No, I'm not there yet. So 128. That is 2020 squared, which is the same as 101. Again, this is this one, right? The next power, 2020 to the power 256. That's 101 squared, and that is the same. We got it here, 3030. Okay. So what are the things that we need to look at? This, and this. So 256, 128. 32, 16, and 1. Okay, let's put it all together. So the original message was 2020 times 101 times 3030 times 101 times 3030. Now, let's regroup things a little bit, because 3030 times 3030 is 3030 squared, right? So I'm going to write this, I'll write it, otherwise you might say what you're doing. The same we do here, square these two and square these two. And then, because I know already what they are, right? 101 squared, that is 3030. So that's 2020 times 3030. And 3030 squared, that is this one, is 2020. Now 2020 squared, I know what that is. These two squared, that is, that's from here, right? It's 101. So that's 3030 times 101. Okay, now I have to do something. 3030 times 101. And so that is 306030, okay, divided by 7171, that is 42, that is 42 times 7171, and then 306030 is plus 4848. Yep. So our original message was 4848. Now, I took a little bit special number that worked nicely here to make the calculations a little bit short. And I will do also something like that in the quiz. So be a little bit on lookout whether you have repetitions. I'm not guaranteeing that it's always going to be like that, but if they are, make use of them. And so every calculation that you have to do, every of these mod calculations, I need to see the work, right? I need to see this each time, writing this in the division by using the division algorithm, that I see where you get this from. Okay, a bit more work. Also, of course, it's easy to make mistakes here, so be very careful here. Double check always. How can we? What kind of checks can you do? Well, for instance, this one. Double checking that this is correct. How can I do this? Well, I know that if I would, this is the original message. So if I encode the message, so I'll call it check here. If I encode this message, if I take m to the power e, that's 48, sorry, to the power, what's my power again? My e? 97, no? Yeah, 97. Then if I calculate this modulo 7171, I should get the coded message that I originally started with. So we can check this. Now I do use a program to check this. I guess I would be okay if you do that, but I need you to show me the calculations that you show that you also know how to do this. You can check it afterwards, and I get that this is indeed 2020, as it was supposed to be, because that's what I said, right? With the original coded message of 2020. So that's how you can check it. And for the same reason, you can also check your first answer, right? You found this code here. Well, if now you can decode it because you know D, and so you find out that that's the original message. What was the original message? 196. Okay. Also, how do you check that your inverse is correct? Well, double check, of course, right? You make sure that, well, that this thing, especially when you do these calculations here, there's a zero that is somehow dropped here. In each calculations, always double check that the number that your combination, your Bezoek combination actually evaluates to 1, right? You don't want to evaluate it because you need to know these coefficients, but to just check that it is 1, then you are guaranteed that you have that you started with that you're having the right inverse. Okay. All right. So that's for quiz 15.